Improvements to least flood model and the new calibration produced some changes in the hydrological simulations between EFAS 3 and EFAS 4. So the water balance layer is where you can most clearly see them. So here on the right, you can see a comparison between the two systems for the same event in two different stations. The water balance now runs with 6 hourly steps in EFAS 4. So you will see more green dots in the water balance hydrographs. There will be green dots every 6 hours and a red dot every 12 hours. As you know, the red dots represent the last step of the fill-up period. Medium-range thresholds were updated as well, and they reflect the changes in least flood calibration. You can clearly see it in the picture on the top. In general, there are large improvements in the peaks timing, especially for small and medium catchments. You can see an example on the picture on the top row. Even if sometimes peaks can be overestimated, the timing is still very well reproduced. You can clearly see it in the picture on the bottom. But if you compare the topmost picture, you can clearly see the benefit of the new least flood and the new calibration. In EFAS 4, you will also find more water balance stations for the real-time discharge data and more fixed reporting points. All river gauges with some discharge data, either historical or real-time, are now available as queryable fixed reporting points in EFAS 4. During the final phases of EFAS 4 implementation, we have discovered some unexpected issues with the soil moisture maps. Some catchments show extremely dry soils, mostly in Scandinavia, but in other catchments as well. Dry soils are clearly visible in the soil moisture maps, while soil moisture anomaly maps don't show any particular problem. The hydrological skill isn't affected by this issue, and medium-range forecasts also don't show any particular issue in those areas. Soil moisture is currently under investigation. The issue seems to be originated by a combination of factors. The parameter range we used for the calibration of one of least flood components, and possibly a lack of precipitation that least flood tries to compensate by squeezing as much water as possible out of the soil.
Yeah, and as Cinzia mentioned, obviously the main focus in terms of the valuation of the model performance is on river discharge, and here's just a few results. Just a summary of a slice of what's available in the Chems wiki that has all sorts of information in there. But really, just as a summary, the median kg across Europe is 0.75 from all the observation stations. So it is a strong performing model. When we look at the 6 hourly and the 24 hourly observations, we do see very similar results actually. With 6 hourly being slightly better, which is nice to see. So that's on the graph to the right, the cumulative distribution function. And so that's for the main summary score, but you can see these types of plots for all the decomposition of all the correlation bias and variability in the documentation, the wiki. So for anybody who's interested in exploring them more, please go there and have a look. But we also, when we look at the spatial results of the model performance, we can see that in general the KG results are quite uniformly spread throughout Europe. Of course, there'll be certain areas that we know that in general hydrological models perform better or worse, and it's no difference here from the list flood simulation. We can see higher skills in blue in the map on the left of this is showing KG. So large parts of Central Europe and the main European rivers, which of course are, as we know, easier to simulate. But what is nice, and there is more comparison in the documentation, it does seem that medium and smaller rivers are better simulated with the 6-hourly model, which is exactly the type of thing we wanted to see, and Cinzia showed an example of that, but even the long-term scores also reflect that. Of course, we see some lower scores as expected in catchments that are strongly regulated, and so these are these yellow kind of dots. We can see in Iberian Peninsula is a well-known case. But what is also key, the cyan colours were R is greater than 7. So the KG, as we mentioned before, of course is an important summary metric, but these summary metrics hide a lot of information, and often what we want is, even when the KG, as I mentioned before, is lower, we do see that the correlation is higher, at least even 0.7 is the threshold we use here. So this map reflects that as well, to show maybe the forecasters where, even though the KG might be low, these are the areas we can still have some confidence. So these are the type of results we'll help guide the use and the confidence in the model. And now we'll move on to then the forecast results. So looking at the results for the medium range forecast skill, looking at the graph on the top right first, which is the continuous rank probability skill score on the y-axis against lead time out to 10 days at a 6-hourly time step. And so just take one slice as an example. The CRPSS is 0.4 across Europe as a median. Of course, there's then spread. And so when we look at the map, and this is just a snapshot of one of the layers that will be now available on EFAS and on the web interface we'll show soon. And we can see that there are areas that the forecast skill is lower than average. These tend to be catchments in southern Spain, northwest UK, Norway, Iceland, Alps, and bordering the Black Sea. And from a very, these types of skill investigations are just underway. We're having a look as we understand the kind of performance of EFAS 4. We're seeing that it looks like it's a smaller, very, very small catchments and that are upland and steep, and also catchments with snow and ice are a particular challenge. These are things that, of course, we need to understand and use as forecasters using the system every day. Will be excellent to get your feedback as we go through the trial period and onto the early use of this, so we can start to look at and diagnose problems for the future. So that's the results for the model and the forecast skill.